Algebra 1, lesson 34, we're going to talk about recognizing and extending arithmetic sequences. Basically, we're looking at a series of numbers and we're trying to see if we can find a pattern. Arithmetic sequence is one kind of pattern that we'll look at. So sequences of numbers can be formed by using a variety of patterns and operations. Further into math you go, the more complicated some of those operations and sequences tend to get. Okay, a sequence is a list of numbers that follow a rule. And each number in the sequence is called a term of the sequence. For instance, 3 is the second term in this first sequence that we see here. Right? 7 is the fourth term in the sequence. So we could look at this, and if we know what the rule is, we could jump to and say, well, what is the 20th term in the sequence without having to find the previous 19 terms, right? If we know what the rule is. Okay? So, and each number in the sequence is called a term of the sequence. Here are a few examples of sequences. Well, it seems like always we have to fix some typos. Array, there we go, we got R. So what we have here is at least 4 different examples of sequences that we could get. We have 1, 3, 5, 7. Can anybody kind of tell what type of sequence 1, 3, 5, 7 is? What are we doing there? You could say that we're adding 2 or that we're going by odds, right? Doing something like that. Then we have 7, 4, 1, negative 2. Okay, that's a little bit more complicated, or it seems complicated. What are we doing there? Subtracting 3, okay. 2, 6, 18, 54. Times 3, 2 times 3 is 6, 6 times 3 is 18, 18 times 3 is 54. Good job, 1, 4, 9, 16. Squares. Well, yeah, well, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. The next number would probably be 25, 36, 49, right? 64. Good job. All right, so in the above examples, the first 2 sequences are what we're looking at. There are types of sequences called arithmetic sequences. An arithmetic sequence is a sequence that has a constant difference between 2 consecutive terms called a common difference. The common difference between what we see in 1, 3, 5, and 7 is the number 2, right? That's the difference between 3 and 1, 5 and 3, 7 and 5, right? They have a common difference of 2. The common difference between 7, 4, 1, and negative 2 was 3, right? Or negative 3, depending upon how you look at it. So to find the common difference, we would choose any term and subtract the previous term. So 4 minus 7 is negative 3. So they have a common difference of it that can actually be a negative value. Okay? First sequence above, the common difference is 2, while the second sequence, the common difference is negative 3. Okay, so far does this all seem fairly easy? Okay, hopefully. With an arithmetic sequence, because it's based upon adding or subtracting, you really have to know, you can't just jump to, let's say, the 20th term without knowing what the 19th term was. If the sequence does not have a common difference, then we wouldn't refer to it as an arithmetic sequence. So if I can't subtract and continually get the same number in between these numbers, then it's not arithmetic. Question? It depends upon what the sequence of numbers is, right? And a lot of these sequence of numbers, you have to find out what the rule is. So there's not like a consistent, there's not a situation where there's one formula that fits all sequences. And if I just plug these numbers into this equation, I'll always know what the rule is. It doesn't work like that, okay? Just like you saw 4 different sequences of numbers that had 4 different rules, right? One was squares, one was multiplication, one was addition, one was subtraction, right? There's not just one in particular that's going to handle all of those.
So what do we do if it's like the 106th term?
You would probably have, in an arithmetic sequence, you would have to find all the way up to the 105th term, right? There's not just a rule that's going to jump. Well, we could probably write a rule, because what you're looking at, we could probably know. We'll definitely be able to come up with something. Okay, and I'll show you what that's going to look like here in a second. Okay, in fact, with what we see here, right, that's what we're going to be able to do. Okay, so the first term of a sequence is denoted as, and the way that I've had to type this in is a little bit different than how it looks in your book. They would write that as A sub 1. right? I'm just writing it as A1, but I think that you'll understand what's going on there. So if you look in the book, it'll see it noted a little bit differently, but the concept is still there. So the first term we call A1, the second A2, the third A3, so on and so forth, until you get to like the nth term, which would be like, could be the 150th term, just whatever it is, of the arithmetic sequence is denoted as A, sub n. The term preceding A sub n is denoted as A sub n minus 1. So that's the one that happens before the nth term is n minus 1. So if we were looking for the 150th term, right, the one before it would be the 149th term because it'd be 150 minus 1. You get the gist of that? Okay. So for example, if n was 6, then the one that happens before that is the 5th term. Right? I mean, they make it look complicated, but whenever you describe it, you're like, oh, wait, that's kind of just stupid simple, right? And just to find the one that happened before it, I just subtract one. Yeah. All right, so if we know what our pattern is, sequence pattern here, it's not always this sequence. In this case, you're adding 4. Okay, so whatever the pattern is. This particular pattern is just, you start with 7 and you add 4. The first number in the sequence is 7. The next one is going to be 11. The next one after that, right, you're getting 15, 19, so on and so forth, all the way down through just by adding 4 over and over and over and over and over again, okay? So essentially, you get down to the nth term because 4 plus 4 plus 4 is the same as 4 times 3, right? So if I'm at the 5th term, right, I know that the first term was n, so the 5th term is 7 times 4 to the 4th. You follow me? Because the first one was essentially really what you could say is times 4 to the 0, right? And what's anything to the 0 power? 1. So it's just 7 times 1, which is giving you 7, correct? All right, so if I wanted to know what the 150th term was, I would take 7 times 150 minus 1. Okay. Let's see. So that's going to be 149. Okay, so I would end up doing that many times, right, and then get my answer from there. Okay. So the 5th term is 7 plus 4 to the 4th, right? It's giving you a pretty big term. All right. Does that make sense? Okay, so we could actually, with that rule, figure something out to get me where I want to go. And the rule is what we're finding here. Okay, this whole line right here is telling me how to get that rule without going through all of the previous ones to get there. Okay. All right, arithmetic sequences can be represented using a formula, but again, those formulas may be different. Okay. In an arithmetic sequence, we can see where they're going to be the same, where we can use that formula. Use the formula below to find the next term in a sequence. So we're saying A is the first term, D is the common difference, okay? N is the term number. In the arithmetic sequence, where we have 7, 11, 15, 19, A to the first is 7, A second 11, so on and so forth. The common difference is 4. So let's pick something a little bit smaller. Let's say we want to know what the 7th term is going to be. Okay, so let's see if we could figure that out. That would be 7 times, let's see, we would get 7 minus 1, which is going to be 6. Okay, plus our D. All right, which is our term, let's see, our common difference. That was 4. Okay, so we got 7 times 6 plus 4. What's 7 times 6? 42. 42 plus 4. We should be getting something bigger than that, though. 46. Let's see if that actually works with what we saw over here. All right, let's see. So 4 plus 4 plus 4 plus 4, that's 16, right? All right, so what's 7 plus 16? 23. 7 plus 16 is 23. So let's see. Let me go forward again. Hold on. I might have. All right. It should be plus back in here. So not instead of multiplication, we would get 7 plus 6 plus. That's still not even right, is it? Because that's only 7 plus 10, which is 17. So that wouldn't be right. Let me hit pause here for a second. Let's get this straightened up. All right. So to me, what's kind of missing here, just looking at it like this, is that what we should have is 7 plus 4 times 6 plus 4 again. So 4 times 6 is what? 24. So that would be 24 plus 4. So I'd be getting 7 plus 28. All right, what's 7 plus 28? Okay, 7 plus 28 is 35. Let's see if that fits the pattern that we would be looking at from over here. So here we have 4 plus 4 plus 4 plus 4, which is 16. 7 plus 16 was what? 23. 16 plus 7. Okay, 23 plus 4. 27. Did we not get that? Or over here we got 35. Okay, but that may still be, because there we're getting, here, let's look at this. We get 7, 11, 15, 19, 23. We should be getting 27. So how did we get so far off there? 1, 2, 3, 4. We should be getting 5 for the 6th term. Oh, because we jumped to the 7th term. So where would we be getting 27? And then 4 again would be what, 31. So anyway, I don't know. I probably messed you guys all up. All right. So here's another way of looking at it. The rule for finding any term in an arithmetic sequence can be developed by looking at a different pattern in the sequence. So where we have 7, 11, 15, 19. They start off here with the first is 7. Okay, then you have 7 plus 4, which is 7 plus 1 times 4. Then 7 plus 2 times 4, 7 plus 3 times 4, 7 plus 4 times 4, which is where we saw our 16, right? The next, where we would be getting 7, if we're looking for the 6th term, that would be 6 minus 1, which is 5, 5 times 4, right? If we wanted the 7th term, that would be 6 times 4, which is 24, 24 plus 7. What is 24 plus 7? 24 plus 7? 31. So for the 7th term, we 31. This I like a little bit better, right? It's a little bit more direct. You don't see all the addition taking place in there. Okay, does that make sense? All right. So once I know what my A is, I can plug it in here. If I know what term I'm looking for, I plug it in here. And if I know what my difference is, I'll plug it in there. And so that's the rule that we'll use for arithmetic sequence is A plus N minus 1 times D. Is that maybe what you were asking about, Jeremy? Okay. So yeah, that's the pattern that that's the formula we want to use for arithmetic sequences. Okay? But that will only work if we have a common difference. Okay? So basically this is just saying that same thing again. All right, so I apologize. I've done probably a pretty poor job with you guys over the last couple of days. Let's see, I thought I had it all pulled up. Maybe I didn't. Here it is. All right, so let's look at number 1 here. Find the 9th term of the sequence. The first thing we want to do is find out what the difference is between 3, 8, 8, 13, and 13 and 18. Looks like it has a common difference of what? 5, right? Plus 5. Okay, so plus 5. So Let's see. We want to start off with the first term in the sequence, right? What's the first term in the sequence? 3. All right. And then we want the term that we're looking for. What term are we looking for? 9. 9 what? Minus 1. Okay. Let's see. Let's go back. I want to make sure that we've got our formula right, because I feel like we don't. All right. So it shouldn't be 3 times. It should be 3 plus, right? Okay. So let's fix that. Where are we at here? Okay. So let's fix this. 3 plus 9 minus 1 times what? 5. Okay. Now we follow order of operations. 3 plus, what's 9 minus 1? 8 times 5. What do I do next? All right, multiply. 8 times 5. What's 8 times 5? 40. What's 40 plus 3? 43. You could check the answer key and make sure the answer is 43. It is, so we can move on. Okay. All right, let's go from here. Determine if the sequence appears to be an arithmetic sequence. If so, find the common difference and the next 3 terms in the sequence. All right, so we got 5, 12, 19, 26, 33. Do they have a common difference? What's the difference between 5 and 12? 7, 12 and 19. 7, 19 and 26. 7, 26 and 33. 4 and 3. Okay, so they do have a common difference. So we can get rid of this option, right? All right, find the next 3 terms. Well, what would be the next term? What would I do with 33? Add 7, what would that term be? 40, and then what? 54. All right, so it looks like common difference 7, next 3 terms, 40, 47, 54. Looks like A is my answer. Is everybody following along okay at this point? All right, great. What time do you guys get out of here? 48. All right. We should be, let's see. Now, notice with this one, notice how it's going down, right? Okay. So what's the difference? Is the difference here going to be positive or negative? Negative. What's the difference between 124 and 113? Is it 11? Okay. Negative 11. Okay. Same thing here. Okay. Negative 11. Find the next 3 terms, so I'm just going to subtract 11, right? 102 minus 11, whatever that is, minus 11, so on and so forth. So you guys can do that. Be aware of whenever they're going to be negatives, whenever they're dropping in value. Let's see. All right. Let's look at number 6, because number 6 looks for the 74th term in the sequence. What's the difference? 7, okay? The first term in the sequence is what? 7. 7 plus 74 minus 1 times 7. 74 minus 1, 73 times what? 7. What's 73 times 7? Is it 511? 511 plus 7? 518. Check the answer key. See if that's correct. Number 6. Okay, good. All right, look down here. 3 to 6, 6 to 8, 8 to 13. Is that an arithmetic sequence? 3 plus what equals 6? 6 plus what equals 8? Is it an arithmetic sequence? No. Okay, so we don't even have to do the rest. The answer is no. Okay. All right, do we feel like we got a handle on this? Okay. Now, number 9 gives you the numbers. It says write the first 4 terms of an arithmetic sequence where A is negative 1. So we start off with negative 1 plus, right? Difference of 5. Okay, so the second term in the sequence would be, we would start off with negative 1 plus, we've got a difference of 5, right? Is it 2 plus 5? 2 plus 5. Okay, minus 5 times what? All right. Did we mess some things up in here? Yeah, we did. What's the formula? It's A what? A plus n minus what? 1 times d. Okay? So, we want the number. Okay, we already know that the first term in the sequence is negative 1, right? Okay? So we're going to go 2 minus 1 times 5, right? All right, because we want the second term in the sequence. So 2 minus 1 is 1. 1 times 5 is, all right, negative 1 plus 5, 4. Okay, so that's the next term in the sequence. Now the difference is 5. We could just simply take negative 1 plus 5 is 4. 4 plus 5 is 9. 9 plus 5 is 14. So we could follow the rule, or we could add 5, right? Starting with negative 1. Okay? All right. I'm going to let you go there. Again, I'm sorry for confusing you on that first rule. I think once you look at the second rule where it's multiplication, it simplifies it by quite a bit.